Electrolysis. What actually is electrolysis? Electrolysis is the chemical decomposition of a compound by passing direct current into the solution of the compound or into its molten compound. What does that mean? It means that electrolysis is the breakdown, the decomposition of a compound. That breakdown is a chemical reaction. But this time around, this chemical reaction is not as a result of combining two or more compounds together, but by passing electricity into a compound. And so electricity can be used to bring about chemical reaction, and that's simply what electrolysis is. But very important, we need to look at some things in this definition. What does a molten compound mean? What does a solution mean? A molten compound is a compound dissolved by action of heat. If you take a compound and heat the compound until it dissolves, that's a molten compound. And the solution is simply a compound dissolved in a solvent or probably dissolved in water. You see, an experiment was done. We have a container and we place an electrolyte, a substance, let's assume sodium chloride, into this container and take conductors into it and set up this connection as shown. And so, the moment this switch is switched on, no current flows. The bulb will not lit. But, like I said, this is just a normal salt placed into the container. But with this switch on, if you turn water into this, turn water into it, then the bulb goes on. But if there's no water, the bulb is off, no current flows. Or rather than pouring water, if we take it and we heat up this container and the sodium chloride starts dissolving, then this bulb goes on. That tells you that if current will flow in this circuit, or if electrolysis will occur, if this compound will decompose, then either this is a solution made by pouring water into the sodium chloride, or it was dissolved by action of heat, which is called molten compound. And that's why this definition is the way it is. Electrolysis is the chemical decomposition of a compound by passing direct currents into the solution of the compound or into its molten compound. And that's that about that. Common terms used in electrolysis. First and foremost, we want to look at is the electrode. So these are conductors in the form of wires, rod, or plates through which electron or current enters or leaves the electrolyte. And there are two types of electrode. We have the cathode and the anode. The cathode is the negative electrode. It's the electrode through which electrons enter into the electrolyte or through which current leaves the electrolyte. It's important to note that reduction occurs at the cathode. And then we have the anode. This is the positive electrode. It is the electrode through which electrons leaves the electrolyte or through which current enters the electrolyte. Also very important, oxidation occurs at the anode. And we're using this acronym to remember that. that at the cathode, reduction occurs, and at the anode, oxidation occurs. Now, the next thing we want to look at is electrolyte. This is a compound which conducts electricity and is decomposed in the process. An electrolyte can be an acid, it could be a base, or even a salt, but must conduct electricity and be decomposed in the process. Example of electrolytes are sodium chloride, tetraoxide of a cis acid, etc. We have more, sodium hydroxide and all that. Again, we have non-electrolytes. A non-electrolyte is a chemical compound which do not conduct electricity, e.g. benzene, urea, trichloromethane, etc. And so we look at the next term now. Another term is the electrolytic cell. This is the cell which converts electrical energy into chemical energy. Or simply put, it is the whole assembly of the process of electrolysis. And so this is a simple electrolytic cell. It contains a container, the electrode, and the direct current supplier. Differences between electrodes and electrolytes. In a tabular form, 1. Electrolytes are molten or aqueous solution. We said that earlier. Electrodes are usually solid, except for mercury, which is a liquid at room temperature. 2. Electrolytes conduct electricity through the movement of ions, while electrodes conduct electricity through the movement of electrons. They are compounds. Electrolytes are compound, while electrodes are usually metallic elements or non-metallic material like graphite. Chemical changes occurs in the electrolytes, while for the electrode, physical changes are what occurs in the electrode. Mechanism of electrolysis. You see, let's use this simple electrolytic cell to illustrate what happens during electrolysis. Now, initially, the ions in this electrolyte move randomly. Let me assume it's an aqueous sodium chloride, meaning it was dissolved in water. And so the ions will be moving randomly. What ions are moving randomly? For the sodium chloride, aqueous sodium chloride, there is sodium ion and there is chloride ion, but it was dissolved in water, and so water also would ionize. Well, though partially, as hydrogen ion and hydroxide ion. So there are 4 ions in this electrolyte moving randomly anyhow. The moment this switch is completed, or we say it's on, the circuit is on, electrons will flow from the negative terminal of the cell into this electrode, which is the cathode. As a result, this electrode will be negative with respect to this, which is positive. Now, as a result, since electrons are here, the electrons will attract positive ions. So the positive ions in this electrolyte will come to this electrode. What are the positive ions? The sodium ion and the hydrogen ion, these two. We move to the cathode. Because electrons are here. This is negative, attracting the positive ions because of the electron. So one of these ions would accept that electron and be discharged as a neutral atom. We'll come to that. Now, at this electrode, which is the anode, since itself is positive, it will attract the negative ions. So chlorine and hydroxide ion will move down here, where they release their electrons. So electrons are being released from here, and electron flows through, and we can see the direction of the electron. And so this is what happens here. And one of them, either the chlorine or the hydroxide, would be discharged by giving out its electron and be discharged as neutral atom or neutral element, but we'll come to that. And so that is the mechanism of electrolysis. The next thing we would want to talk about is which of them should be discharged. Is it sodium or is it hydrogen? Or is it chlorine or is it hydroxide? So because these two migrate to the cathode, but one of them will be discharged, and that will take us to the preferential discharge of ions. Now, at the anode, which should be discharged? Is it chlorine or hydroxide? There are factors which will tell us which of these ions would be discharged. See, during electrolysis of aqueous electrolytes, more than one ion gets to either the cathode or the anode, and only one ion eventually will be discharged. And so there are three factors which determines which of these ions will be discharged, since there are more than one ions. Now, those factors are: 1, the position of ions in the activity series; 2, concentration of ions in the electrolyte; and 3, nature of electrode.